So no problem. My name is Daniel. I'm based in Munich. Speaking to you here, it's 9 p.m., 8 p.m. I'm happy to be here. I'm also happy to have the time slot after Kate's nice presentation, because I think it fits very well. I'm also going to present cloud infrastructure also for Edge Cloud. A testbed for Edge Cloud, but on a much smaller scale. So the scale here is more like that you can have it on a tray in your lab. I will going to show you that. First of all, I talk a little bit on why we do this and what the use case is. So what we wanted to investigate was what are the most important processes and procedures, and what is the security of this. So what security properties can be provided in Edge Cloud environments. And when I'm talking about Edge Clouds, I might have a little bit different perspective than what Kate presented so far, because I'm from the telco world. So for me, Edge Cloud means or is part of mobile network and mobile network access. I will also talk a little bit about that. But from the motivation part, we wanted to create an infrastructure in which we could perform our tests on that. The use case we try to set up is based on law enforcement. And law enforcement use case in which the idea is that police forces have cameras with them, and the idea of the cameras is to capture a scene and then perform object detection, for example, to detect weapons or other dangerous objects in crowds or somewhere on the streets. And if there is such an object detected, there should be some kind of alarm issued to the officers on the streets. And we wanted to use the edge devices to have faster access to the video analysis results, and also to not need to transfer the video stream this far, and also to decrease the latency in case in a next step scenario, also augmented reality is used, for example, to provide different feedback than just an alarm. For example, if an augmented reality glasses are worn by the officers, there could be an indication where the weapon was detected or something like this. And as you can see on this picture, when talking about Edge Cloud or edge devices in the telco world, those devices are typically located at the cell towers or base stations, which are those large towers located anywhere around with the antennas mounted on them. And those base stations are typically connected to some type of mobile network or mobile core network, and from there traffic is typically routed to the internet. And in like more traditional ways, the object detection or data analysis is done there. And as said, as we want to speed this up a little bit and have all the advantages of more direct communication, we want to use this edge device capabilities, which are very close to the mobile devices, in this case to the cameras. Just to be all on the same page, I already said some parts of this. The idea of mobile edge clouds, we're talking in the telco world, is basically that you have computational capabilities in terms of storage or in terms of processing capabilities, closely located to your end devices, which is typically a telephone or a vehicle or something like this. And some of the use cases, the first one is the one we were focusing on, video analytics, but there are also others, for example, augmented reality or just caching some data so that it does not need to be transferred around the internet or in a more distant way. There is a reference architecture for deploying edge clouds or mobile edge clouds from ETSI, which is the European Standardization Organization. I just wanted to show this picture because later on I'll come back to what parts of this we already implemented in our testbed and what's up next to be implemented. But what you can see is there is this MEC host. It's connected to other hosts. There's a specified interface for that. There's also a platform manager which is used to organize or manage the platforms. There's also this orchestrator which is used to manage multiple platforms, and of course there is some level of abstraction for managing the virtualization. Yes. Then to the experimental setup or our testbed setup. So the basic idea, what we did, we have this body cam, which is basically the camera worn by police officers. This camera is capturing the environment to later on perform data analysis on that. And then we have 2 mobile networks in our case. Each mobile network has the possibility of establishing a radio link to the camera, and also is connected via cable connection to an edge device, which is, as I said, the instance that provides storage and computational capacities. And both mobile networks are also connected via backbone network, and this backbone network is also connected to the internet. The third edge cloud that we have here is a regional edge cloud, which is also part of the mobile network concept, but this part we have not implemented for this paper. It's just here to make clear that there is also another level of possible edge clouds, which could be located in the region, for example, in a larger metropolitan area or something like this. Then how it looks in real life. As said, we have this mobile tray. On top there are 2 laptops which are connected to software-defined radios. They run a software called SRS-RAN, which implements a 4G radio network. In between you see a mobile phone. This mobile phone provides the camera capabilities and also the radio link capabilities to one of the software-defined radios. And below that you can see that our edge devices look very closely to what Kate presented in the last talk. But I think in her talk it was 4 Raspberry Pis. In our talk, in our testbed, it's 8 in this example. One is a primary node which is directly accessible and is managing the others. We use Kubernetes for this, and there are GPU accelerators attached to each Raspberry Pi just to facilitate the object detection. And we have one additional instance, which is the mobility management, on which I will explain later on what we use this one for. So that's our testbed, and then how we allocate resources in this testbed. Now the mobility management comes into place. So the idea here is that the end devices, which in our experiment is the mobile phone with the camera application, registers at the mobility management. And the mobility management collects status reports from the edge devices just to know what is the load on each edge device and how is the network connection to the edge devices. And based on this status messages, the mobility management might decide that the task of object detection from the end device should migrate from one edge device to another. If this is decided by the mobility management's logic, then it will send a migrate message to the end device, which will then unsubscribe from the currently connected edge device and will then subscribe to the new edge device. So that's the protocol for task migration that we implemented. Then we evaluated the system because now we have the complete system. We have the process for the migration of tasks. So we can shift or do task offloading from the end device to the edge devices and switch the task between different edge devices. So first of all, we just measured the round trip times in our system. you can see on the bottom below the graphs the different things we measured. UE is the user equipment, which is the end device. BS is the base station. ED1 and 2 are the edge devices. MM is the mobility management. And what you can see here is very easily is that all that connections that include the UE, which is the two blue ones and the yellow line, have a much higher latency. This is because there is a radio link included, while between both edge devices and also between the edge device and the mobility management is much faster. This is, as said, this is expected. Typically in telco networks, the radio link is kind of the bottleneck in terms of network connection. You can see the same in the bandwidth measurements. All the measurements that include the radio link are very low. It's like 25 megabits per second, and all those that only use the cable connections are more than 300 megabits per second, which is also expected, as said. Then we performed 2 initial experiments. Remember, we were interested mostly in security experiments, but for this initial experiments, we just wanted to verify that what we implemented in our testbed so far is running smooth. So first of all, we tried a load balancing where we increased the load on one edge device until a threshold, which was arbitrarily set by us to 70% CPU load was superseded. And then after a short time, the migration was triggered to the other edge device. Second experiment, fault tolerance. It's very like, it's also about changing the task or switching the task from one edge device to another. But in this case, we introduced an artificial network failure in which one edge device, which was currently working on the task, was not reachable anymore. And the mobile mobility management was detecting this based on the status messages, which were not incoming from the faulty edge device. So after a short period of time, the mobility management was detecting this and triggering the migration so that the other edge device could work on the task. So these were our 2 experiments we performed. What we want to do in the future is we want to implement the other parts of the ETSI reference architecture, and we want to perform analysis of the information security in this case. As said, interesting for us is what security properties can be provided within this architecture, and also if this migration procedure is used. And we also want to include augmented reality in our use case. Yes, so just to conclude my talk, it was a cooperation between my organization, which is CITES, and also the Rosenheim Technical University of Applied Science and Furtwang University, which are both 2 nice mid-sized German cities worth to visit one time. We developed a lab infrastructure, including of a mobile network or 2 mobile networks, 2 edge devices, and we plan to include a regional cloud. And we performed 2 initial experiments. One was the load balancing with the artificial load to trigger the task migration, and another one was the failover, in which one edge device had a fault, a network fault, and the migration was triggered from the mobility management. So that's it for my talk. Thanks for listening. You can ask me anytime, you can contact me anytime if you're interested in some parts of the testbed, in the paper, or in cooperation. Please feel free to drop me an email. Thanks a lot.